Hi everyone, Assalamualaikum. I'm Madam Amira Hana binti Muhammad Noor, a mathematics lecturer at UiTM Pahang. Our lesson today is a virtual workshop for final exam preparation Series 1, for subject Calculus 2 for Engineers, MAT235. Hope you enjoy this video. We start with the first segment, which is assessment for MAT235. Now we look at the assessments for MAT235. Okay, basically we have 4 assessments: assessment 1, assessment 2, assessment 3, and assessment 4. Okay, now we look at the type of assessment. Okay, assessment 1 is test 1. Okay, assessment 2 are quiz 1 and test 2. Assessment 3 are quiz 2 and test 3, while assessment 4 is a final exam. Okay, so basically for carry marks, okay, we have 2 quizzes and 3 tests. Okay, now we look at when all these assessments are given. Assessment 1 in week 5, assessment 2 in week 9, assessment 3 in week 13, and assessment 4, which is final exam, on 12 February 2022. Okay, and what is the topic cover in all these assessments? Okay, under assessment 1, the topic cover is chapter 1. Okay, under assessment 2, the topic cover is under chapter 2 and early chapter 3. Okay, under assessment 3, the topic cover are chapter 3 and chapter 4, while for assessment 4, which is final exam, the topic cover all syllabus except chapter 2. Okay, means chapter 1, 3, and 4. Right? Right, we look at the total marks for each assessment. Okay, assessment 1 carries 20 marks. Okay, come from test 1. Okay, assessment 2 carries 10 marks from quiz 1 and 20 marks from test 2. Okay, assessment 3 carries 10 marks from quiz 2 and 20 marks from test 3, while final exam carries 100 marks. Okay, we look at the percentage for each of these assessments. Under assessment 1, we have 10%. Okay, come from test 1. Under assessment 2, we have 5% from quiz 1 and 10% from test 2. Okay, under assessment 3, we have 5% from quiz 2 and 10% from test 3. Okay, so before final exam, all students should have carry mark equals to 40%. Okay, alright. And then the final exam carries 60%. Okay, so the total marks equals to, or the total percentage, okay, from assessment 1, 2, 3, and 4 equals to 100%. Okay, which come from 10% plus 15% plus 15%, which is equals to 40%. Okay, from carry mark, and then plus the final exam equals to 60%. Okay, so the grand total of percentage equals to 100%. Right? Now we highlight on time management to answering final exam for ODL. Okay, the total marks for ODS final exam equals to 100 marks, and the duration equals to 3.5 hours. Right, so now we look at the time management. Okay, 100 marks, okay, means 3 hours we use to write the answers. And another 30 minutes we use to scan and upload your answer, right? So, means that 100 marks we need to answer within 3 hours, okay, not 3.5 hours, right? Because another 30 minutes we use to scan and upload the answer, right? Some students think not enough time. Right, now we look at the total marks for ODS final exam. We have 100 marks, okay? And then the duration equals to 3 hours, okay? This is the time to answering and writing, right? Alright, from here we have 100 marks equals to 3 hours, means equals to 180 minutes. Means that for 1 mark, you need to spend 1.8 minutes. Okay? Right, so from 1 mark equals to 1.8 minute, you can split to 1 minute and 0.8 minute. Okay? You spend 1 minute to answer and you spend 0.8 minute to check your answer. Okay? So that you will have enough time. Right? Right. So now we have 100 marks. Okay? We need to answer within 3 hours time. Right? Cukup ke masa ni? Nak upload jawapan lagi. Some students think about that. Okay? Tapi. Okay? 3 hours ni is for answering and writing only. Okay? You have another 3 minutes to submit. Okay? 3 minutes means submission time. Okay? Submission time means first you need to arrange your answer paper and then you scan and save in single PDF file, and after that you need to upload within 30 minutes. Okay? So if you use this method or this calculation to spend your time to answering your final exam, inshallah you will enough time. Right? Now we go to another segment, which is sample of final exam paper. Right? Right, from this sample of final exam papers, we have 3 printed pages, okay? And then we have 5 major questions. Question 1, 2, 3, 4, and 5, okay? And the total marks equals to 100 marks. And the percentage equals to 60%, okay? And then all these questions you need to answer within 3 hours time, okay? And another 30 minutes you use to scan and upload your answer, right? Next, we look at the sample of solution. Now we go through one by one, okay? This is the first question. First, we look at question 1, okay? A. Use integration by parts to solve integration of 3x plus 6 times ln sec 3x plus 12 dx. 6 marks, right? Right, here are the solution. From the given question, integration of 3x plus 6 times ln square root of 3x plus 12 dx, okay? We have multiplication between bracket 3x plus 6, okay, which is algebraic function, and ln square root of 3x plus 12, which is logarithmic function, okay. From Euclid formula or Euclid rule, L come first, okay. So means that L should be U, because whichever function comes first from islet rule means the function should be U, right? Right, since we choose U equals to ln sert 3x plus 12 equals to U, so the other function should be dv, right? And note that dx always included in dv. Okay, so we can write like this. Okay, we just exchange u and dv here. So we can write integration of ln square root of 3x plus 12 times 3x plus 6 dx. Okay, we just exchange this function. Okay, because we want to write u first. Okay, and then we write dv. And remember, dx always included in dv, right? So from here, we can write equals to integration of u dv. Okay? And from integration by parts formula, when we have integration of u dv, it is equals to uv minus integration of v du, right? How we get this? We recall back from integration by parts formula, integration of u dv equals to uv minus integration of v du, right? So from this formula, we need to identify u and dv, okay? Alright, our u equals to ln sert 3x plus 12, okay? And dv equals to 3x plus 6 dx, right? For u, we need to find du, okay? So what should we do? Okay, we need to differentiate, okay? From dv, we need to find v, okay? So what should we do? We need to integrate, right? Now, how to differentiate u equals to ln sert 3x plus 12, okay? We look here, okay? Now we have u equals to ln sert 3x plus 12, right? And we can write u equals to ln 3x plus 12 to the power of half. How we get this? From the properties of indices, if we have sert a or square root of 8, it is equals to a to the power of half. So means that if we have square root of 3x plus 12, it is equals to bracket 3x plus 12 to the power of half. Alright? And then from here, using the properties of logarithm, we can write u equals to half ln 3x plus 12. How we get this? Okay, from the properties of logarithm log base a m to the power of p. We can write equals to p. Okay, we move p in front here, and then times log a m. Alright, since ln is also a log, okay, ln equals to log base e, so we can also use these properties. Okay, so we can write ln 3x plus 12 to the power of half. We move half to the front using the properties of logarithm. Okay, so we get half ln 3x plus 12. Okay, this is u. Okay, we not differentiate yet. Okay, and then from here we can differentiate. Okay, so after we differentiate u with respect to x, so the symbol become du over dx equals to, if we have multiplication by constant, we just write the constant in front here and then multiply by, then we differentiate logarithmic function. Okay, when we differentiate ln 3x plus 12, so we have 1 over the function in ln, which is 3x plus 12. And after that, we multiply by, we differentiate the function in ln. Means that we differentiate 3x plus 12. So we have 3 plus 0. Okay, no need to write plus 0. Right? And after that, from here, we can factorize 3x plus 12. So we factorize 3. So in bracket, we have times x plus 4. Because if we expand, we will get back the above function. Alright? And then from here, we can simplify 3 here and 3 in denominator here. Okay, because the operations here are multiplication function, okay, or multiplication operation. So we can simplify. Alright? So after we simplify, so we get du over dx equals to 1 over 2 times x plus 4. Okay? And remember, when we use integration by parts, okay, from u, we need to find du. So from du over dx, to find du, we need to move dx to right hand side. So we have du equals to 1 over 2 and then bracket x plus 4 and time dx. Okay, this is our du. So we can put here. Okay, from u, after we differentiate, so we get du equals to 1 over 2 x plus 4 dx. Right? Or the other technique to differentiate u equals to ln sub 3x plus 12. Okay, from u equals to ln sub 3x plus 12 using the properties of indices, we can write u equals to ln bracket 3x plus 12 to the power of half. Okay, from this formula. Okay, if we have sub a or square root of a, it is equals to a to the power of half. Okay, and then from here, we can straight away differentiate. Okay, means we find du over dx. Okay, because we differentiate u with respect to x. Okay, so we have du over dx equals to, using the properties of logarithmic function, when we differentiate ln function, so we have 1 over the function in ln. Okay, the function in ln means 3x plus 12 bracket to the power of half or sub 3x plus 12. And then times, we need to differentiate bracket to the power of half. Remember, if we differentiate bracket to the power of any constant, we can differentiate using generalized power rule. Right. How to differentiate using generalized power rule? First, we move the power to the front. Okay, so we move half to the front here. So we get half. And then we copy the function in bracket. So we have 3x plus 12. After that, from half here, we minus 1. Okay, from the power, we need to minus 1. So we have half minus 1 equals to negative half. After that, don't forget to differentiate the function in bracket. So when we differentiate the function in bracket, which is 3x plus 12, so we get 3 plus 0. Okay, no need to write plus 0. And the operation here must multiplication operation, right? So at this point, we done differentiate, but we need to simplify. Okay, so from here, we can write du over dx equals to 1 over sub 3x plus 1 times 1 over 2, and then we can move bracket to the power of negative half. Using the properties of indices, when we move bracket to the power of negative, okay, we can write in terms of positive exponent. Okay, so means that we have bracket 3x plus 12 to the power of positive half. And remember, to the power of positive half means square root. Okay, that's why from here, we get this. Okay, this is the same function. Okay. Alright. And then times 3. Okay. So we put here. Right. After that, right, look at here. We have set 3x plus 12 times set 3x plus 12. Okay, we have same term containing set. Okay, so we have set 3x plus 12 bracket squared. And when we simplify set and square, so we will get no more set. Okay, so we have 1 over 2 and then set 3x plus 12 times set 3x plus 12 equals to set 3x plus 12 bracket squared. And after we simplify, we get 3x plus 12, no more set symbol. Okay, and then times 3. Okay. From here, we can factorize constant 3. So in bracket, we multiply by x plus 4. Because when we expand, we will get back the above function. Alright? Next, we can simplify 3 here and 3 in denominator here. So we get du over dx equals to 1 over 2 times x plus 4. Okay? We recall back under integration by part. Okay, from u, we need to find du. Okay, so from du over dx, we write du as a subject. So we need to move over dx to right hand side. So we have du equals to 1 over 2 times x plus 4. And then when we move over dx to right hand side, so we have times dx. Okay, and then when we compare, this is equal. Okay, so you can differentiate u equals to ln 3x plus 12 using this technique or the technique that I mentioned in the previous slide. Okay. Now, from dv, we need to find v. Okay, from dv to find v, we need to integrate. Okay, so we have dv equals to bracket 3x plus 6 dx. Okay, and then to find v, we need to integrate bracket 3x plus 6 dx. Right? How to integrate 3x plus 6? Okay. First, we can move out constant 3. Okay. And then in bracket, we have x plus 2. Okay. Or we can, from here, we can straightforward integrate one by one. Okay. Without factorize 3. Right? Okay. Let's say we factorize 3 first. Okay. So in bracket, we have x plus 2 because if we expand, we will get back this function. Right? And then v equals to, we still have constant 3 in front, and then we integrate x with respect to x, so we get x squared over 2. And then plus, we integrate 2 with respect to x, so we get 2x. Right? And after that, we can write v here. Okay, v equals to 3 bracket x squared over 2 plus 2x. Right? After we identify u and dv and we find du and v, so we can substitute into this formula. Okay, we multiply u and v. Okay, from here, so we get this. Okay, 3x squared over 2 plus 2x times ln set 3x plus 12. Alright. We can write u times v or v times u. Right? To avoid error, we better put this function in front, ln function. Alright? And then minus integration of v du. So v, we multiply by du here. Okay? And then we substitute into here. So minus and then integration sign. And then v times du. Okay, v equals to 3x squared over 2 plus 2x times du. Du equals to 1 over 2 times x plus 4 dx. Alright? Alright, and then from here, there is no integration sign. So we just copy from the above. Okay, or we can expand first. Okay, 3, we expand with the function in bracket. Okay, so we get 3 over 2 x squared plus 6x ln 3x plus 12 minus, okay, and then from here we can factorize. Okay, we factorize, we have x squared and x here, so we factorize x, and then half here we can factorize half, but in bracket must be 4. Okay, because when we expand, okay, half x times x, we get back x squared over 2. Okay, and when we multiply half x times 4, we get back 2x. And we still have constant 3 in front here. Okay, so after we factorize x squared over 2 plus 2x, we get this. Okay, because if we expand half x times x plus 4, we get back this function, right? Right, and then we have same factor, okay? X plus 4 here and x plus 4 in denominator. And the operation here is multiplication operation. So we can simplify, right? After we simplify, so we get this, okay? We just copy this function because there is no integration sign, okay? So no need to integrate, okay? And then from here, 3 times half, so equals to 3 over 4. So we can move out constant from integration sign. And then we have x here and then dx, okay? We can only move out constant, okay? Never move out variable from integration sign, remember? Alright, and then from here, we recall back, there is no integration sign, so no need to integrate. But from here, we have integration sign, so we need to integrate x dx. Okay, so after we integrate, we have 3 over 2x squared plus 6x ln 3x plus 12 minus, okay, we still have 3 over 4 here, and then we integrate x with respect to x. We have x squared over 2, and over 2 we can multiply by over 4 here, so we get 3 over 8 and then x squared. And after we done integrate, we must put plus c at the back because this is indefinite integral. Okay, so this is the final answer after we integrate this function using integration by parts. Okay. Alright, from here we can check the final answer using symbollab.com. Okay, we use this command, integration of 3x plus 6 ln 3x plus 12 in bracket dx. After we press enter, so we get this output. Okay, so it is equals to half ln 3x plus 12 times 3x squared over 2 plus 6x minus 3x squared over 8 plus c. Okay, so this is the same. Okay, and look at here. Okay, in symbollab.com we have half ln 3x plus 12. Okay, and then after we integrate using integration by part, we have ln 3x plus 12. Okay, actually this is equivalent, right? We recall back. Okay, ln 3x plus 12 from here equals to ln 3x plus 12 bracket to the power of half. Okay, this comes from the properties of indices. Okay, if we have set a, we can write equals to a to the power of half. Alright, and then from here we can write half ln 3x plus 12 using the properties of indices log a m to the power of p. So we can move power to the front here. So we get p log a m using the properties of logarithm. So means that ln 3x plus 12 equals to half ln 3x plus 12. Alright? Means this answer is correct. Right? To integrate 3x plus 6 ln 3x plus 12 dx using integration by part, we cannot use tabular integral. Why? Because there is no repeatable function. Okay, there is no exponential function or trigonometric function. So we need to integrate using integration by part formula. Never integrate using tabular integral. Alright? Okay, so this is the final answer. Okay. Next, we continue with question 1b. Right? Question 1b. By using trigonometric substitution x equals to 2 sine theta, solve integration of x times radical 2 minus x squared d theta. Okay, from the given question, we have x equals to 2 sine theta. Okay, now we look at the solution. Okay, alright, we have radical 2 minus x squared. Okay, 2 here means constant, means a. Okay, in between is minus. Okay, so we can refer this formula. Okay, if we have radical a squared minus x squared, where a is a constant, so we can use substitution x equals to a sine theta. Okay, why we have a equals to 2? Because a squared equals to 2. Means that a equals to 2. Okay, that's why we choose x equals to 2 sine theta. Alright? Right, so the first step, we choose x equals to 2 sine theta. Okay, and then step 2, since we have term containing x squared here, so we need to find x squared. Okay, from step 1, we squaring on both sides. So 2 squared, we have 2, and then sine squared theta. Right? Next, we need to find dx. Okay, to substitute into this question. Okay, so from step 1 here, after we differentiate, so we have dx over d theta equals to 2, and then we differentiate sine theta equals to cos theta. Okay, times d theta here come from over d theta from left hand side. So after we move to right hand side, we have multiply by d theta. Right? After that, we need to eliminate radical 2 minus x squared. Okay? So, step 4, radical 2 minus x squared equals to x squared here, we can replace by 2 sine squared theta. Okay? So, it is equals to radical 2 minus, after we replace x squared equals to 2 sine squared theta, so we get this. Okay? Now we have constant 2, okay, for both terms. Okay? So we can factorize constant 2 and multiply by, in bracket, we have 1 minus sine squared theta. Alright? And then from trigo identity, 1 minus sine squared theta equals to cos squared theta. So we can write square root of 2 and then cos squared theta. Alright? After that, we simplify this radical. So we have 2 cos theta. Alright? After that, from the given question, integration of x times radical 2 minus x squared dx will equals to integration of sec2 sin theta times sec2 cos theta times sec2 cos theta d theta. Alright, how we get this? Okay, from the given question here, we need to write in terms of theta and d theta. Okay, from x here, okay, from step 1, we replace x equals to sec2 sin theta. Okay, and then radical 2 minus x squared equals to sec2 cos theta. Okay, from here, right? And then dx from here equals to sec2 cos theta d theta. Alright, we replace one by one. Okay, from the original question, we have in terms of variable x and dx. After we use trigonometric substitution, now we have in terms of variable theta and d theta. But now we have in terms of trigo function, right? From here, we need to simplify. Okay, we have constant sec2 times sec2 times sec2. Okay, sec2 times sec2 equals to 2 and then sec2. Okay, then we can write 2 sec2. Okay, we move out constant to sec2. Okay, we multiply sec2 times sec2 times sec2. So we get 2 sec2. Okay, and then we have sin theta. And then cos theta times cos theta equals to cos squared theta. And then d theta. Right? So from here, we need to integrate trigo function. Okay? Since there is no formula for integration for this trigo function, so what should we do? Okay? From here, we can use U substitution. Okay? We choose u equals to cos theta, and remember when we use u substitution, we need to differentiate. Okay, we have derivative part and integration part. Okay, under derivative part, after we identify u equals to cos theta, we need to differentiate u with respect to theta. So we get du over d theta equals to, after we differentiate cos theta, we have negative sin theta. Next, we need to write d theta as a subject. So we just cross multiply. So we have d theta equals to du over negative sin theta. Okay. After that, we need to replace here. Okay. So we have equals to 2 sec2 integration of u squared sin theta du over negative sin theta. Right now, we check one by one. Okay. From u equals to cos theta, okay, we can replace cos squared theta equals to u squared. Okay. From here. Alright. And then, from d theta equals to du over negative sin theta, okay, we can write d theta here equals to du over negative sin theta. Alright. From the previous slide, okay, after we use u substitution, so we can write integration of x, radical 2 minus x squared dx equals to 2 sec2, integration of u squared times sin theta times du over negative sin theta. Okay, since we have multiplication operation here, so we can simplify sin theta here and sin theta in denominator here. Okay. Then, after we simplify and after we move out constant negative 1, okay, so we have negative 2 sec2 integration of u squared du, right? From here, we have function in terms of u and du. So, we can integrate with respect to u, okay? Using power rule, after we integrate u squared du, so we have u cubed over 3 plus c. Okay, and we still have constant -2 sec2 in front here. Okay. Alright, after that, we replace u equals to cos theta. So means that u cube will equals to cos cube theta. Okay. And then we can write constant -2 sec2 and then over 3. Okay. And then we have cos cube theta plus c. Okay. Alright, at this point, we done integrate. Okay. But look at this. The original question is given in terms of variable x. Okay. And no trigo function. But after we done integrate, now we have trigo function with variable theta. So means that the next step we need to replace theta in terms of variable x. Okay, what should we do? We use triangle method. Okay, with angle theta. Okay, we use right angle triangle with angle theta, and then we need to find all three sides. Okay, how to find all three sides from this right angle triangle? Okay, we use the first step. Okay, from x equals to sec2 sin theta. When we write sin theta as a subject, it will equals to x over sec2. Okay, from trigo ratio sin theta, x means opposite. Okay, so we can write here. Okay, sec2 means hypotenuse. So we can write here. Okay, and then our goal now is to find cos theta. Okay, so from here, first we need to find the adjacent. Okay, how to find the adjacent? Okay, we use Pythagoras theorem. Okay, so we have sec2 squared, which is equals to 2, and then minus x squared and then square root. So our adjacent equals to sec2 minus x squared. Alright, now we have all three sides. Okay, so we can find cos theta from here. Okay, cos theta equals to adjacent, which is sec2 minus x squared, and then over hypotenuse, which is sec2. Alright, after that, we can replace cos theta equals to sec2 minus x squared over sec2. Okay, then it is equals to -2 sec2 over 3, and then cos theta now equals to sec2 minus x squared over sec2, and then we have cube here, so we put bracket and then cube plus c. Okay, after that we need to simplify. Okay, from the previous slide, okay, 2 sec2 means sec2 cube. Okay, so we can write -sec2 cube over 3. Okay, from here, we still cannot simplify sec2 here and sec2 here because first we need to solve cubic function here. Okay, I mean cubic operation here. Okay, so after we solve cubic operation here, so we have sec2 minus x squared cube over sec2 and then cube. Okay, after that we can simplify sec2 cube here and sec2 cube in denominator because the operation here is multiplication. Alright, so after we simplify, so we get -1 over 3, and then we can write sec equals to bracket to the power of half and to the power of half and then cube, so we have to the power of 3 over 2. So after we simplify, the final answer equals to -1 over 3 and then bracket 2 minus x squared to the power of 3 over 2. Okay, over 2 here come from sec here. Okay, because sec means to the power of half. Okay, and then plus c. Okay, so this is the final answer. Okay, since the original question is given in terms of variable x, dx. So the final answer should be in terms of variable x as well, right? To confirm your answer, you can check using symbollab.com. Okay, we use this command: integration of x square root of 2 minus x squared dx. Okay, after we press enter, so the answer equals to negative 1 over 3 bracket 2 minus x squared to the power of 3 over 2 plus c. Okay, and we can compare with this answer, right? And the answer are equal. Okay, means that this answer is correct, right? Alright, how about question 1c? Solve integration of 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1 dx by using partial fractions, right? Now we look at the solution. Okay, we have 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1. Okay. From denominator, after we expand both factors, so we have degree 3. Okay. And from numerator, we have degree 2. Okay, from here. So this is called proper fraction because the degree of top is less than the degree of the bottom, right? So means that from here, we can straight away use partial fraction without doing long division, right? So using partial fraction, we have x squared plus 1 here, okay? This is irreducible quadratic factor. How do we know this is irreducible quadratic factor? Because if we find the value of b squared minus 4ac, we will get complex numbers, right? So means that this is irreducible quadratic factor, okay? So from here, we have linear factor x minus 1, okay? The first denominator, and then plus, and we have the second denominator equals to x squared plus 1, which is irreducible quadratic factor, right? When we have denominator with linear function, okay, so this is called linear because the degree of x equals to 1. So we will have numerator equals to constant. Okay, we can put a here. Okay. This is constant because no variable x, alright? And for the second fraction, we have denominator with x squared plus 1, okay, which is quadratic function, okay? If we have denominator with quadratic function, we will have numerator with linear function, okay? We can put bx plus c, okay? This is called linear function because we have term containing x, or highest degree of x here equals to 1. Alright? Look at this. We have three constants a, b, and c. Okay? Because from denominator here, we have degree 3. Okay? So it should be tally. Okay? The number of constants should be tally with the degree. Okay? Alright, from here we can name as equation 1, right? After that, we need to standardize the denominator, okay? So from 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1, okay, we can write equals to, after we standardize denominator, we have denominator with x minus 1 times x squared plus 1. Okay, so what should we do with a here? Okay, a here we need to multiply by x squared plus 1. Okay, so we can write here a times x squared plus 1. Alright, and then plus Okay, from here, we have bx plus c. Okay, and then we have denominator x minus 1 here. So we need to multiply. So we have plus and then bx plus c times x minus 1. Right? Since the denominator for both sides are equal, so we can say that the numerator for both sides also equal. Okay, so we can write 2x squared minus 3x plus 5 equals to a times x squared plus 1 plus bx plus c times x minus 1. Okay, then we can name as equation 2. Right? From the previous slide, we get this. Okay, after we equate both numerator, okay, from left hand side and right hand side. Then we name as equation 2. Alright, now we want to find the values of constant A, B, and C. Okay, how to find the values of A, B, and C? First, we look at here. Okay, we have linear factor x minus 1. Okay, when we equate this linear factor to 0 and we solve for x, we will get x equals to 1. Right? After that, we substitute x equals to 1 into equation 2. Okay? After we replace 1 into variable x here, so we have 2 times 1 squared minus 3 and then times 1 plus 5 equals to a, and then 1 squared equals to 1 and then plus 1. Okay, and then plus, since x minus 1, okay, we equate to 0, so means that this is 0. Okay, so 0 times bx plus c will equals to 0. Okay, right, after that, we simplify, so we have 2 minus 3 plus 5 equals to 1 squared plus 1 equals to 2 and then a. Okay, so from here, we have 7 minus 3, which is equals to 4, and then equals to 2a. Then we have a equals to 2. Okay, now we find the value of constant a, which is equals to 2. Alright? Alright, after that, we want to find the values of constant b and c. Okay, so from the second factor here, we have irreducible quadratic factor x squared plus 1. If we equate this factor to 0, we will have x squared equals to negative 1 after we move plus 1 to right hand side. Okay, and x equals to square root of negative 1. What is the value of square root of negative 1? It is actually equals to complex number or I. Okay, so means that there is no value of x here. Okay, I mean there is no real number for x. Okay, so what should we do? Okay, in this case, we can use another technique. Okay, we can expand equation 2. Okay, so from equation 2 here, okay, this is from equation 2. After we expand right hand side, okay, we will get ax squared, okay, and then plus a, and then plus bx times x equals to plus bx squared. Bx times negative 1, we have minus bx, and then plus cx, and then c times negative 1 equals to minus c. Alright? After that, we can rearrange, okay, with the same coefficient. Okay, so now let's say we arrange, okay, we have ax squared and then plus bx squared and then plus cx and then minus bx and then plus a minus c. Okay, we arrange based on the same coefficient with x squared and then x and then constant. Okay, then we can write 2x squared minus 3x plus 5 equals to a plus b and then x squared plus c minus b x and then plus constant a minus c, right? Right, we check one by one. We have a plus b, okay, x squared and then plus c minus b and then x and then plus constant a minus c. Okay, this is constant, right? Then we name as equation 3, right? From the previous slide, after we substitute x equals to 1 into equation 2, then we get a equals to 2. And then we also have equation 3 after we expand equation 2. Okay? Alright, from here, by comparing the coefficient of x squared, okay, so we can compare a plus b equals to 2. Okay, we compare the coefficient of x squared. Okay, then we substitute 2 into a here because a equals to 2 and then plus b equals to 2. Then we solve for b. So we have b equals to 0. Okay. After that, by comparing the coefficient of x, okay, so we have c minus b equals to negative 3. Okay, then we replace b equals to 0. Okay, then we have c minus 0 equals to negative 3 and c equals to negative 3. Okay, so our a equals to 2, b equals to 0 and c equals to negative 3. Okay, so at this point, we success find all the values of constants a, b, and c, right? From the previous slide, we get a equals to 2, b equals to 0, and c equals to negative 3, right? After that, we need to substitute the values of a, b, and c into equation 1. We recall back. From equation 1, we have this equation, right? So now, after we substitute a equals to 2, so we get this, okay? 2 over x minus 1, right? And then plus, we replace b equals to 0, and 0 times x equals to 0, right? And then we replace c equals to negative 3, so we have minus 3 here, okay? Then, we can write 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1 equals to 2 over x minus 1 plus negative 3 over x squared plus 1. Or we can write minus 3 over x squared plus 1. Right? This is the sum of partial fraction, okay, from this rational function. Right? Right. We also can check the answer using symbollab.com. Okay? Using this command, partial fractions, 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1. After we press enter, so we have 2 over x minus 1 minus 3 over x squared plus 1. Right? Means that this is correct. Okay? From the previous slide, we success express this rational fraction into the sum of partial fraction. Right? So, therefore, we can integrate 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1 dx equals to, we can move out constant 2 and then integration of 1 over x minus 1 dx. And then we move out minus 3, okay, constant minus 3. And then integration of 1 over x squared plus 1 dx. Right? And then, how to integrate 1 over x minus 1 dx. Okay, using quick method, in integration, if the numerator is the derivative of the denominator, so after we integrate, the answer equals to ln denominator plus c. So, in this case, after we integrate 1 over x minus 1 dx, since 1 is a derivative of x minus 1, so after we integrate, we have ln denominator, means ln x minus 1. We still have constant 2 in front, right? The other technique to integrate 1 over x minus 1 dx, we also can use this formula. Okay, if we have integration of linear ax plus b to the power of negative 1 dx, we also can write integration of 1 over linear function ax plus b dx, and it is equals to, after we integrate, we have 1 over a equals to the coefficient of x, okay. In this case, we have 1 over 1, okay, because our a now equals to 1, okay. And then ln ax plus b plus c, okay. Now our linear function equals to x minus 1, okay. 2 here come from this constant, okay, 2 in front here, alright. Or the third method, we also can integrate 1 over x minus 1 dx using u substitution, okay. We can choose u equals to x minus 1, and then after we substitute, we will get integration of 1 over u du, and it is equals to ln modulus u plus c. Then we replace back u equals to x minus 1, right? So you can try it by yourself, okay, to integrate integration of 1 over x minus 1 dx, right? Alright, now how to integrate 1 over x squared plus 1 dx, okay? We recall back from derivative formula, if we differentiate inverse tangent x with respect to x, the answer equals to 1 over 1 plus x squared, okay? 1 over 1 plus x squared equals to 1 over x squared plus 1, okay? Means that if we integrate back 1 over 1 plus x squared, it will equals to inverse tangent x. So, in this case, it is equals to minus 3 because we have constant negative 3 in front here. And then after we integrate 1 over x squared plus 1 using this formula, using the derivative formula, okay, we reverse step, okay, because integration means antiderivative. So, we can write integration of 1 over x squared plus 1 equals to inverse tangent x, okay. And after we done integrate, so we can put plus c at the back, okay, because this is indefinite integral, right? So this is the final answer, okay. After we integrate 2x squared minus 3x plus 5 over x minus 1 times x squared plus 1 dx, it is equals to 2 ln modulus x minus 1 minus 3 inverse tangent x plus c, right? Madam, boleh kita rehat sebentar? Baiklah anak-anak, kita take file dulu, kita sambung lepas ni ya. Coming up next, sample of final exam paper MAT235 Calculus 2 for Engineers, ODL. You can subscribe, like, and share to support this channel. Thank you for watching. Stay tuned. Bye. Assalamualaikum.